Happy Friday, Palmerettis. It is Friday, April 24th. Good morning, good day, good afternoon. If it's a good evening, good evening. Okay, today we got a math and a science lesson. Hopefully you guys are continuing to turn your work in. Those that owe work, get it turned in. Math lesson 14.4, colored pages 533, 535, homework page 183 and 184. Again, this is the only page you're going to turn in. A lot of times with your pictures, guys, make sure it's a picture of the full page, and make sure before you send it, it is not blurry. I would lay it down, take your camera, laptop, whatever you're taking a picture with, and take a picture of it face down. Okay, so this is a lesson. It's going to have some challenges to it. It's going to have a lot of different ways that we can get to an answer. So that's one thing that's fun about this lesson. So make sure you have a lined piece of paper ready to go. Got a scratch in my throat. Sorry about that. All right. So look for and use structure. I can use patterns to help solve problems. Now, this is our last lesson in topic 14. So again, the homework will just be a front and a back. And we'll see that in a little bit. And then we're going to get to topic 15. And hopefully you still have your protractor, because that's going to come up for this chapter. So make sure you have that for next week. Evan's baby brother is stacking blocks. Using the rule, add one block to the number of blocks in the previous stack. How many blocks will be in the sixth stack? Explain, justify your answer. So what I do, to me, this is one where we can really do a few different things. We could redraw it, which is going to take some time, but we can also count it. 1, 2, 3, 4, 5, 6 blocks. 1, 2, 3, 4, 5, 6, 7 blocks. 1, 2, 3, 4, 5, 6, 7, 8 blocks. Now, do you see how I marked off each one? That you can do. All right. Now, our fourth one, our fifth one, and then it said to go up to our sixth one. Well, let's look at, the rule said to keep adding one. But we'll also see a pattern here. 6, 7, 8, 9, 10, 11. Bada bing. There's our answer, 11. Now, we'll also see, coming back, we'll see some of those input, output. Input, they haven't used these words yet, but we're going to see these down the road. Input, output, right? Check that out. Now, I could also do it vertically, but I did it horizontally for now. One stack had 6 blocks. 2 stacks had 7 blocks. 3 stacks had 4. Ooh, whoa, stop. 3 stacks had 8. Holy cow. 4 stacks had 9. 5 stacks had 10. 6 stacks had 11. So we could also do it that way. If you wanted to draw pictures of them, you could absolutely do that. So it says, look for relationships. How many blocks are in the 10th stack? Well, go to the 10th stack. This would be 6. Let's keep going. So 7 would be 12. 8 would be 13. 9 would be 14, right? 10 would have 15. So we'd have 15 blocks. Again, we just keep counting, right? There are always 5 more blocks than the number of the stack. So the 10th would have 15. Now that's another thing to look at. There's always 5 more. See that? Always 5 more. That's another way that we can look at it, okay? It's all a plus 5, plus 5, plus 5. But lots of different ways to attack this one. So check that out. All right, flip that over. She's going to walk us through one here. It says Alyssa made 3 walls with cubes, right? She recorded her pattern. If she continues the pattern, how many cubes will be in a 10-layer wall? A 100-layer wall. So rule, each layer has 4 cubes. 4 more cubes would be 8, and then 4 more would be 12. So we see it right here, 4, 8, 12. We already see what's happening here. What do you need to do to find the number of cubes in a 10 and 100-layer wall? I need to continue the pattern using the rule and analyze the pattern to find features not stated in the rule itself. So our last colored pages of every chapter, of every topic we've had, and this is finishing topic 14, guys. This is great. 2 topics left. They always give us some things that we need to do as students of math doctors, right? How can I make use of structure to solve the problem? They tell us some things. Look for and describe the patterns in 3-dimensional shapes. Let me look at the time. Let me look at my mic. We're good. I can use the rule that describes how objects or values in a pattern are related. I can use features of the pattern not stated in the rule to generate or extend the pattern. Make a table. There's that word again. Make it a table and look for patterns. So 1 has 4, 2 has 8, 3 has 12, 4 has 16, 5 has 20. So from input to output, how does the 1 become a 4? The 2 to 8, the 3 to 12, the 4 to 16, the 5 to 20. It's all times 4, right? Okay? So a 10-layer wall, 10 times 4, 40. A 100-layer wall times 4 is 400. So there's a multiplying of by 4. Okay? So that's one way. How could you use multiples to describe her pattern? Well, they're multiples of what? Well, let's look back. Multiples of 4, 8, 12, 16, 20. They are all multiples of 4. Now, you should be feeling really good. But when we're feeling really good is when that's when they try to sneak in and try to zap you. So be ready, all right? All right, let's go to the next colored page. 535. I apologize for my cough. I'm okay. Leah arranged triangular tiles in a pattern like the one shown. She used the rule multiply the number of rows by itself to give the number of small triangles. How many small triangles would be in the pattern if there were 10? So she's going to multiply it by herself. So multiply 1 row times 1, 2 by 2, 3 by 3. The next one would be 4 by 4, which is 16. The next one would be 5 by itself is 5 is 25. Alarm hopefully goes up in your head that we've got basic math facts, and if they're not memorized, get on them now and get them memorized. I'm going to be on you about that. Another way that you could look at the pattern here is each row contains 2 more triangles than the row above it, or the second row has 2 more triangles than the first row, the third has 2 more triangles than the second row. That gets a little bit tricky, crazy to me. Bottom line is this. We're multiplying it by itself. I'm good with that. So how many triangles would be in 10 rows? So we're going to go 10 times what? Well, it said right here, multiply it by itself. 1 by itself, 2 by itself, 3 by itself, 4 by... So 10 times 10 is 100. Very good. Now, independent practice. Look for relationships. Alan built the towers shown using the rule. Each story has 2 blocks. How many blocks will a 10-story tower have? All right, so let's walk through these now. This is a lot like the homework. All these questions are making you think. What are we using? What are we not using? How would it look? What could we do differently? Complete the table to help describe the pattern. 1 to 2, 2 to 4, 3 to 6. You already see something happening there, don't you? Yeah. Times in by 2, right? So it's all times 2. Times 2. 1 becomes a 2, 2 becomes 2. 4 times 2, 8. 5 times 2, 10, right? We also see a pattern, 2, 4, 6, 8, 10. See that? So what is another way to describe the pattern that is not described? Well, we could say we're doing it times 2, 2 times the number of stories. So if we have 10 stories, since it's times 2, what's 10 times 2? Good job, 20. So 20 blocks are going to be used there. Again, you should be feeling very good, especially if you know your math facts. Now, put a big old star right here because this is where it gets a little bit challenging. Because that's a good thing. We want to see that. Okay. You ready? All right. An art gallery staircase is built using glass cubes. That's pretty cool. The diagram below shows 4 steps. High, 4 steps are 4 cubes high, 4 cubes across. How many let's see. 5 steps are 5 cubes high and 5 cubes across. How many glass cubes are used to make 7 steps? So let's look at each one here. 4, 4, 5, 5, 6, 6. Now, for me, there's so many different ways that we could attack this. I'm going to show you a few different ways. One, you could count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Here's those 6 and a 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. 10, 15, 21. Now, you might say, well, Mr. Colletti, we're going by 5s. Well, 5 more than 15 would be 20. It's not going to work there, okay? So we're going to look at this, okay? So it says, what do you need to know? What do you know and what do you need to find out? Well, what we know is we have 4 and 4, 5 and 5, 6 and 6, right? we need 1 to figure out. We want to find out the 7. So what do we want to find? We want to find the 7 cubes, all right, for the 7 steps, because we've done 4, 5, 6. We want to do one for the 7 steps. Some of you are already looking at this, and you've already seen something that they're doing. Check this out. They went 1, 2, 3, 4, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. So the next one is they're just going to put another 7 right there, aren't they? So what they're doing is by the number we're going by, that's what we're adding. Let me show you. Okay, so 2 cubes up or across, total cubes needed would be 3. 3 up and would be 6. 4 cubes up, and we needed 10. 5 cubes up, 5 cubes across, we needed 15. 6 cubes up and 6 cubes across, we needed 21. So now let's look at this down here. Check this one out. 3, 6, 10, 15, 21. We're not counting by a specific number, because if it was by 3, it would be 3, 6, 9, 12, 15, etc. It's not doing that. What we see is here it's 3 more, 4 more, 5 more, 6 more. Do you see that pattern? 3, 4, 5, 6. Guess what that next one would be? Plus 7, right? The 8th one would have plus 8 would be 36. Do you see that? Okay. Isn't that crazy? But again, we could come up here and go, wait a minute. If we put another cube here, that's 7 more. 1, 2, 3, 4, 5, 6. What did I just do wrong here? Yeah, 1, 2, 3, 4, 5, 6, 7. Yep, I got it right. That would be 28. So that one, I want you to pause it, count it, see it, check it. Now, it says right here, number 9, what pattern can you determine from the table? Every time you add a step, you add the number of cubes up or across to that total. So every time we add a 9 here, whatever number here, we're adding that to that. It's going to be 45. Okay, so we're going to keep adding that one here. So how many cubes are needed for 7 steps? So we took the 7 and we just added it to the 21. We got 28, right? And it's okay to leave some of these blank. I'm not stressing about that. I'm more so if you can explain it and talk to me about it. All right? All right. And get your homework in front of you and have a lined piece of paper ready to go. And I just lost my homework. There it is. All right, make sure your name is on it. Practice 14-4. Dwayne right here walks you through a problem up here about Dwayne. She's going to walk you through it. When you look for relationships, you recognize, describe, and use patterns. So we have 2, 3, 4, 5. So I like to write the cubes that I see here. 2, 3, 4, 5. So we see it right there. We see it. The next one's going to have 6. The next one's going to have 7. So we could keep going there. Put a star by this one. They really jump you to a challenging one. This one is going to make you really think, because they didn't mention how we can sit here and use perimeter. And that's what we're going to use here. And we're going to mix that in, and we'll talk about it as we go. You ready? Okay. Sarah is making diamond shapes with yarn like the ones shown. She adds the lengths of the sides to determine how much yarn she needs. What is the greatest side length Sarah could make with 48 inches of yarn? Okay. Now, sounds like a big number, but let's walk through this. 2, 2, 2, 2. Okay? So number of inches on one side, if we have a 2 here, it's going to take 8. If we put a 3 here, 3, 6, 9, it's going to take 12. 4, 8, 12, 16, right? So let's do one with 5. And I'm all about drawing it out. 5, 10, 15, 20. Put one here with 6. Put a 6 all around. Now, Mr. Coletti, can I multiply by those by a 4? Absolutely. 6 times 4, 24. Now, the table stops, right? So I want to continue that table. It's okay. I'm going to bring it down here, okay? So 7. So if I draw the picture, 7, 14, 21, 28, that's a terrible, terrible rectangle. Pardon that rectangle. That's awful. Do another rectangle. Put 8s. What's 8 times 4? 32. Let's put a 9. 1, 2, 3, 4. 9 times 4? 36, right? Let's do another one. 10. 10 times 4? 40. 11. And some of you already figured out the answer, didn't you? 11 times 4, 44. Do 12 times 4. There's your answer, 48. So what is the greatest side length Sarah could make with 48 inches? The answer is 12 inches. See that? Now, Mr. Coletti, what if we didn't want to draw all these pictures out? I've got no problem with that. Let's go back and let's look at the table. 2 becomes an 8. How? Plus 6? But 3 plus 6 is 9. That's not going to work. 2 becomes an 8 times 4. 3 times 4? 4 times 4? 5 times 4? 6 times 4? So we could have not done these pictures, and we could have just continued working that out and gotten that right there. And there's your answer. Ha, ha, ha. Guess what? We started the homework, and it's going to be finished. All right. On the back, man, this one right here is a tricky problem. Pete's Pool installs rectangular pools that are all 10 feet wide. Let me make sure it's in the picture. Yeah. The length can vary from 10 feet to 30 feet. The company installed a pool with a perimeter of 76 feet. What was the length of the pool? So let's walk through it. A 10 foot, 10 by 10. This side's going to be this side is always going to be a 10. This side is going to change. So 10, 12, 14. Do you see what they're doing there? 10, 12, 14. What should be the next one? I would go to 16, absolutely. So let's talk about that in a minute. What quantities are given in the problem, and what do the numbers mean? So when we look at this, the width is always going to be 10 feet. That's not going to change, okay? All right? The width is going to always be right there. We know that we want to find one that is a perimeter of 76 feet, okay? We also know that the length is going to change. The length will change. The length will change, okay? We know that. What do you need to find? We need to find out the length. That's what we want to find out, okay? So a lot of you right now have skipped down to number 6 to complete that table, and you've already found some answers. 40, 44, 48. Do you see a pattern? 40 to 44 is how many more? 4 more. To 48 is how many more? 4 more. That's not a rule. That's a pattern, okay? What's 48 plus 4? 48, 49, 50, 51, 52. Plus 4, 56. Plus 4, 60. Plus 4, 64 plus 4, 68. Now, did we find our answer? No, because we want to land on what? 76. So do a 25, 68 plus 4, 69, 70, 71, 72. Do a 26, 72 plus 4 is, and there's our answer. And our length is going to be 26. Our width is going to be 10. What is the length of a pool with a perimeter of 76? Well, let's explain now. You could have sat there and said to me, hey, I counted by 4s right there and got the pattern. All right, but again, we want to come back to perimeter here, and that's where we can do some work, okay? So this is one of those problems that I worked it out knowing the pattern right here, but if we went by perimeter, okay, and we wanted to use that perimeter stuff, so remember that. Perimeter equals 2 length plus 2 times the width. We already knew the width, didn't we? And we already knew the perimeter, so 76 is going to be 2 times the length, okay, plus 2 times 10. We already know what the width is. The width is going to be 20. See that? And this is going to go back to our area and perimeter. So I've told you to review it, haven't I? So 76 equals 2 times length plus 20. Here's what's cool. We already have 20. So we do 76 minus the 20, and what does that leave us? 56. So this guy right here, 2 times what would equal 56? Divide these two. 56 divided by 2, cut it in half, and you're going to get 28. Guys, it comes back to this right here. Knowing that formula, okay, and then plug in what they've given you. What we plugged in was the 76, the 2 times the length, and the 2 times the 10. Right here, we knew the 76 and we knew that 10. By knowing that, we'd take 10 times 2, we get that 20. Subtract that from the 76, we have 56 left over, cut that in half. That goes back to area and perimeter. So your homework is now done for math. There is nothing you have to turn in to me. You just have to say that I got it done. Take a picture of it if you want. Send it to me that it's done, okay? It should look like this. It should look like this. And if you have this written down and you send this to me, there you go. Your math homework on Friday is now done. You have some science homework, okay? But the math is done. Review it. And you saw where that area and perimeter showed up, okay? All right. Have a great weekend. I'm here to help you if you need me, all right? Talk to you later.